Hello. Welcome to welcome to SEANERGY. I'm Richard Sargeant from INTERTEK, and I'm going to talk about an innovative system for corrosion and marine growth inspection. Would you care to join us, sir? You're standing at a safe distance. Come in. Bring your beard to the show, sir. And we're going to talk about that using robotics. If you want to scan the QR code, and there's another code at the end, so you can connect with us and get more information. This is the team that I work with. So, yeah, okay, thank you. So what does pitting or corrosion look like? Of course, I'm talking specifically about offshore wind. In this instance, these are images taken by a diver, and you can see they're using a pitting gauge to look at deformations in the material, and the first thing we know is that the results are actually pretty terrible because it's all done visually and it's a mechanical thing. I think the results from this were the holes were supposedly 4 millimeters deep, but what is the tolerance of that, and how do you record it, and how do you find it again? What does marine growth look like? This actually is a photograph taken in Dutch waters of Pacific oysters growing. This is an invasive species which we're now finding quite common in the North Sea. Of course, it originates from Japan. This adds a huge amount of bulk and mass to structures. So there's a lot of research in the industry as to what is this and what do we do with it. And finally, what does microbiologically influenced corrosion, MIC, look like? This actually is not a wind turbine. This is a sample piece of steel. But you can see that after it's cleaned, it has very peculiar C-shaped pits in the material. So this is a natural phenomena that you will find in stagnant waters, for example. So inside a monopile, it's surprisingly common. And when we don't understand the levels of oxygenation, this is the result that we can have. So moving on. Why does it matter? Well, stating the obvious to my one participant here. It causes hydrodynamic drag on the structure. So obviously the water passing doesn't pass in the same way. For floating structures, which are becoming popular now in deeper waters, it adds a burden of weight. And this can also cause a loss of structural integrity because the marine growth here attaches itself in a particular way. I'm overlapping here between corrosion and marine growth. And it can also contribute to scour. Scour, of course, is a huge factor and a huge variable thanks to Mother Nature. And it can also cause other environmental factors. And I think the most crucial point is it offers a potential deviation from the original design model. So we calculate a certain structure size and weight and performance based on the seabed performing a particular way and the structure behaving a particular way. And marine growth and corrosion gives a deviation. The big one, of course, in the end is a loss of structural integrity. Early foundations were mostly coated. Many now actually allow free corrosion and thicker material. This is additional cost. And we've seen assets where they expect to lose 10% of the material thickness over the lifetime of an asset, and 10% steel loss is a lot. So this is the star of the show, and a very bad photograph. This is Ariel. This is an innovative magnetic crawler. So this has permanent magnets fitted to it, and it's designed to act as a kind of tractor carrying different NDT techniques. So this is available to view on our booth as well. So this is operated remotely. We can either do it from the deck, through the hatch, because we have a 25-kilo version of this, or off the side of a vessel, and we crawl down the length of a pile, and we scan using phased array ultrasonics to look at two things. We look at the material thickness loss, and we look at the weld quality, particularly the critical can welds. So this is an innovation from our company. We're an inspection company, so this was developed for us. We own the IP, and this gets deployed later this year. This now is a video of this on trial at the National Oceanographic Centre. So this is a fairly simple video in nice clear waters. It's so clear you can barely believe it's in the water. And here we're looking at deformations that we have made in a test plate to see if the system can spot it. And we're also doing some operator training. This is moving quite slowly at the moment here, but this is just to show you that yes, it's waterproof, and yes, it works. And we should have some video from sea trials soon enough. So this was taken last year. And how we deploy it, so this can be operated from the vessel or it can be operated from the wind turbine itself. It will work at up to 15 centimeters a second, and basically it scans up and down to map the corrosion over a given area. So different clients have different concerns. Principal concerns are twofold. Number one is, what is the structure like in the splash zone, because you have high levels of oxygenation and peculiar marine growth. And then, of course, the fulcrum point, the interface between the foundation and the seabed, where the thing acts as a lever. So the quality of those welds is critical. It's quite common for us to inspect those welds in the factory when the foundations are being constructed to check the material thickness and the weld quality, and then again after piling in operation. And of course, as an asset gets older and older, it becomes more important to understand how is this actually working. So this is a typical deployment. And again, just to mention, this is essentially a tractor. So this can perform corrosion mapping using phased array ultrasonics. We can do spot checks using PEC. This actually has an articulated arm as well, so we can fit sensors or a camera to this to look at particular areas, such as fenders, for example, or J-tube seals, which commonly fail. And it's recording video and photography and so on. So this is just, again, a schematic of how it might typically be deployed. So what is the answer? So we inspect it. So we deploy it using our own marine operations team. I'm English, but of course we're a pan-European team. This is backed by Capsys, which is an INTERTEK company. It's a corrosion laboratory. So we provide consultancy on what does this mean. And it's supported, of course, by our METOC brand, which is famous for geotechnical survey work. So not only do you get the report and the data on the right, but if needed, we could also offer consultancy on what does this mean. So top right, you'll see a test foundation here where we have a depth of 2 millimeters, I think it was, which was not expected. And this was actually an inclusion from the steel mill, because we're looking through the material, so we can see pockets and gaps and delamination in the steel itself. Putting on my salesman's hat now, these are other services that we offer. We have quite a large fleet of ROVs and drones performing different inspection services, 3D scanning, coating integrity, material thickness, and so on. Quite a lot of different services that we have. And then we have specific data sheets on these topics, so on MIC, for example, and how we can inspect for corrosion. You can download these from the site. The sulfate-reducing bacteria look like this. It's quite a scary thing when you see it. We think of sharks, and actually bacteria are probably far scarier. And here you can scan to connect with us or ask us any questions. There's so many of you here, I can't answer all of the questions, sorry to say, but you, sir. Maybe you have some questions? Yeah, we can take water samples, yeah. Exactly that, yeah. And then we can do two things. We can either provide a very quick test for MIC using a test kit on site, takes about 15 seconds, and then we can go to the laboratory afterwards to look at the composition of it, yeah. Absolutely, yeah. So we measure the thickness of the marine growth using a probe, but also we have Voices, which is an extremely expensive camera, so we can 3D scan as well to determine the surface buildup. So we can use a probe to simply check the thickness, but we can also scan an area. The nice thing with the robot is it's capable of returning to exactly the same spot, so we can see precisely where we need to inspect again, so we can check year after year. That's a good question, sincerely, so thank you, yeah. There's a friendly face at the back. Now I'm in big trouble. Okay. Charlotte, give me a question. This is good. Any question you like. Where did I purchase these trousers? Charity shop. Yeah. Yeah. Foundation. En français.
You work on the construction of the robot, or
Yeah, the robot was built to our requirements, so we specified the robot and a company manufactured it for us, and we own the intellectual property of it. So it's, yeah, there's some patents on this. I don't want to see any Chinese copies. Good question, thank you. Yeah, it has an umbilical, so it requires power, yeah. But they're permanent magnets, so if we kill the umbilical cable somehow, it's always fixed, and then there's a recovery procedure if needed. This is why we rent it and not sell it, so the risk becomes ours, not the client's, if we drop it in the sea. Good. Thank you so much. It's been very nice to. Oh, you're too kind. Thank you.